Okay, this is a AP Calculus AEB limits and continuity practice test. Okay, the figure below shows the graph of f. Use this figure to answer the questions 1 through 4. Okay, number 1, limit x approaches to 7f is what is answer. So in this graph, when x approaches to 7, 7 is right here. So it doesn't have a one side limit. So you have to check both sides. So right hand side, it approaches to also -1. Left hand side, also same thing, approaches to -1. So answer is -1. Okay, you have to check both sides. Number 2, limit x approaches to -6. What is your f of x? So right hand side here, left hand side here. When x is -6, so it approaches to 1. Answer A. Okay. Number 3 is a one side limit. Well, so when x is approached to 0 from left hand side, so you follow this one, that side, not this one. So when x approaches to 0 here, so follow this left hand side. So your y value 4. Okay. Now when x approaches to -6 from negative side, so -6 again, this one, but this side only one side limit. So left hand side approach to here, that is 1. Okay, let's move on. Number 5, limit x approach to 0 from negative side. So if you quick sketch 1/x graph looks like this. So when x approaches to 0 from negative side, it goes like this. So it goes to -infinity. Okay. The graph of which equation listed below has asymptote, vertical asymptote, x equals 1. So to find out vertical asymptote, you need to have a denominator. But sometimes if you have a same factor, it is not vertical asymptote. It could be whole. So let's factor out. So if you look at E, x minus 3, x minus 1. So as you see, this one, numerator, denominator, same factor. So you can cancel. So that is a whole. Okay, that is not vertical asymptote. So there's a whole at x equals 1. Sometime they ask you what is the location of whole, then you need to get also y value. Then what you have to do is you cancel out this one and you plug in x equals 1 into the equation. So y equals 1 minus 3 -2. So location of whole is 1 comma -2. Okay, but the question is what is which equation has a vertical asymptote x equals 1? So when you factor the c, so that one, okay, so you have vertical asymptote x equals 1 or x equals 2. So C is answer. Okay, number 7. Now this is a one side limit. So when x approaches to 2 from positive side, so that means it's slightly bigger than 2. So you don't need absolute sign. Okay, when you take it out, that's what this means. So you cancel out, and then you plug it in 2. So answer is 2. Okay, after you cancel, so D is answer. Number 8, determine whether or not the following statement is true or false. If it is a false, explain why and give a counterexample. Statement, p of x is a polynomial, then the function f of x equals p of x over x minus 1 has a vertical asymptote x equals 1. So how are you going to make this one I'm gonna make false, right? So you can say, let's say my P of x, like I explained earlier, I have a same factor, like I'm gonna make like this example. Then x equals 1, there's a hole, it's not vertical asymptote, right? So that's a counter example. So you can say this one is not always, right? So if you have a one counter example, that means it is not true. So answer is a false. And I made this one counter example. Okay, which makes the statement is false. Number 9. So this one, when you plug it in, the first step you always have to do is for the limit, you just plug it in simply. But if you plug it in 3, root 4 minus 2 over 3 minus 3. So which means basically 0 over 0. So 0 over 0 is not defined. So what you have to do is if you learn L'Hopital's rule, you can take the derivative top and bottom separate way using L'Hopital's rule. But this is a AB. So in the beginning, what you have to do is, since you didn't learn it yet, the derivative, you have to multiply conjugate of square root expression. So conjugate of this, square root x plus 1 plus 2. Okay, that's what we call conjugate. So if you multiply conjugate of that square root expression top and bottom, then you can simplify. So limit x approaches to 3. Now when you FOIL it out, so this time this, x plus 1. And then when you multiply this and that cancels out each other. That's the reason you multiply conjugate. Okay? 2 square root x plus 1, it will cancel out each other. So only thing left is this times this, which is minus 4. And then I'm going to copy just denominator. Like that. Okay? So after that, as you see, that one right here, that one is x minus 3 basically. So this one cancel. After that, you can plug it in, limit x approaches to 3. So you end up with 1 over square root x plus 1 plus 2. So when you plug in 3, 1 over root 3 plus 1 is root 4. So that's a 2. 2 plus 2 is a 4. So your final answer will be 1 over 4. Okay. So that's how you're going to do. It's 0 over 0 is undefined. So you have to find out some other way. So I multiply conjugate of square root expression. Number 10. For the function below, find the x values at which f of x is not continuous and justify your answer, and at which discontinuity are removable. So when you talk about the discontinuity, there's a removable, that is a whole. Okay, whole is a removable. But what is a non-removable? Non-removable is when it's a vertical asymptote. Okay, the location of vertical asymptote is basically non-removable. Okay, so to know this one. So let's find that out. And in order to answer A, first step is let's see, you have a vertical asymptote, right? Or so what you have to do is you have to factor. So if you factor top one, let's see, 2x, x, and then you can say 3 and 5, and then on side you have to put negative, so negative here plus here. That's the right factor. And then x minus 5, x plus 4. Okay, so that's the first step you have to do. You have a polynomial expression, numerator and denominator. go ahead factor it. Now as you see, this one you have same factor. So that's the location of hole. So you can say at x equals 5, there's a hole, and that is removable. Discontinuity. Okay. So at x equals 5, it said find the x values, not continuous. So that there's a hole not continuous, and then that is removable. Okay. Now B, name vertical asymptote using verify using limit. Okay. So vertical asymptote is vertical asymptote at x equals -4. Right. So how gonna verify? How gonna verify using limit? There's a vertical asymptote. So to do that, you can say, let's see, vertical asymptote when x approaches to, so let's say limit x approaches to -4 from negative side. Let's see what happened. Then your f of x. To x plus 3 over. So this one cancel anyway. And then when you plug it in x equals to -4, so this one is 2 times -4 is a -8 plus 3, -5. So basically -5 over 0, right? But think about this way. When x approaches to -4 from negative side, right? It approaches to here. So that means -4 point slightly more negative value, right? 0, 0, 0, 1 like that. So denominator will be also negative, right? So basically -0. So there will be positive infinite. Okay? As long as it goes infinite, that means that's a vertical asymptote. Now, let's talk about then x approaches to -4, positive side, f of x. So similar way, I'm going to repeat, just except, so after you cancel out, you got this one. Now, when x approaches to, now positive side is coming from here. So that means your x value will be negative, slightly higher value, so 3.9999 like that, right? So then when you plug it in here, top one is of course still -5 over, bottom is 0 but positive 0 this time, so negative infinite. So either negative infinite or positive infinite. That shows is a vertical asymptote. Okay, when x approaches to -4, since the y value is infinite, that shows that's a vertical asymptote. Now C, name any horizontal asymptote and verify using limit. Okay, so how you gonna verify? Oops, I have to open it in here. Okay, so to do that, C, y equals limit x approaches to infinite, and then 2x squared, the original equation, 2x squared minus 7x minus 15 over x squared minus x minus 20. So to show horizontal asymptote, you have to take the limit x approaches to infinite, and then I'm gonna do also x approaches to -infinite. You have to do both and then see what happens. Since x approaches to infinite, it's the same power here, then just take the coefficient of that. So 2 over 1. So y equals 2, that's your horizontal asymptote. Okay? And also y equals limit x approaches to -infinite, 2x squared minus 7x minus 15 over x squared minus x minus 20. Some people, they don't understand why you take coefficient of the highest power as long as they are same power. Then you can think about this way. Why don't you divide by top and bottom x squared? Okay, probably you need to show. Some teacher they ask you not just take the coefficient of the highest power. You have to show your work. Then what you have to do is this way. So x equals to still negative infinite. Now when you divide by x squared, top 2 minus 7 over x minus 15 over x squared. And same way, if you divide by x squared denominator, 1 minus 1 over x minus 20 over x squared. Now when x approaches negative infinite, so like example like this number 7 over infinite, 7 divided by huge number will be 0. So those are all 0. That goes 0, that goes 0, right? That all goes 0. So then you end up with also y equals 2. Okay, so y equals 2 is your horizontal asymptote. Okay, so that was a answer for C. Now let's move on to 11. Now question is, what is the limit of that? So like I said earlier, first step you can just substitute that x value. If it's a 0 over 0, then we have to do some other tips, but in this case, let's see. So 9 minus 1, when you plug it in, simply x equals 3. 9 plus 12 minus 5, which is 8 over, that's a 21, so 16. Say 8 over 16 is 1 half. So nothing make it 0, so answer is just B. Okay, just plug it in. Number 12, so when you plug in 0, it's undefined. So what do you need to do? So in this case, you have to do one side limit both sides, right? So when x approaches to 0 positive side, when x approaches to 0 negative side, see what happened. 2 plus 5 over x squared. So when you plug in 0, that's infinite. It goes infinite, right? So that's infinite. And also 2 plus 5 over x squared. Even if x is a negative value, slightly negative, right? So when you plug it in 0, then that's still squared. That makes it positive. So answer is, this is goes infinite. So it's infinite. So answer is a C. Now number 13, limit x approaches to 10, f of x equals 20. Then what is the value of limit x approaches to 10, 2 times f of x? So you can change it. Any constant, you can take it out. And then the given is this. So 2 times 20. So 2 times 20 is a 40. Answer is B. Okay. Any constant, you can take it out. Number 14. Find the all value of x. F of g of x is discontinuous. So let's see what this composite function is. F of g of x. So g of x, this one you substitute into here. So 1 over x squared minus 5 plus 1. Okay. So you sub it in that g of x into f of x. And then when you simplify, 1 over x squared minus 4. Now when you factor the denominator, that's x minus 2, x plus 2. So as you see, x equals 2 or negative 2, that makes not continuous, right? Because denominator equals 0. So answer is D. Move on. Number 15. Find the all vertical asymptote. So first step, you factor denominator. So x plus 1, x minus 1. So since you have here same factor, that's the location of hole. That's not vertical asymptote. So that's the trap. A is a trap. X equals to negative 1 is not vertical asymptote. Only x equals 1 is a vertical asymptote. Okay? Make sure you don't circle for the hole. Number 16, limit x approaches to 2. What is the value of secant pi x over 3? So limit x approaches to 2. Secant is 1 over cosine pi x over 3. Okay. Since you're not allowed to use a calculator, change into cosine. Now when you plug it in that value, so limit x equals to 2, 1 over cosine 2 pi over 3. Now that 2 pi over 3 located second quadrant here, right? 2 pi over 3. And then by all student take calculus, the cosine, your terminal side located second quadrant, that is a positive value. So it's not negative, okay? And then your reference angle here, pi minus 2 pi over 3, that's a pi over 3. So that's same as just 1 over cosine pi over 3. Cosine pi over 3, cosine 60 degrees, that's 1/2. So basically 1 over 1/2, answer is a 2. Okay, that's how you're gonna do. Now, next one. Number 17. Limit x equals to 1, f of x. Set graphing may help. Okay, so this is what we call piecewise function. So let's quickly graph the piecewise function. When x is 1, y value is 1. Right here, that's the dot. I'm talking about this one. The rest of it, when x is not equal to 1, then you follow this line, right? So then 2, 3, you y-intercept 3, and slope is, so when x is 1, okay. So you go 2, 3, your graph looks like this. But except when x is 1, that's a 2, so you make it open here. Okay? So basically, so I have to make it open here. Okay? That's actually that piecewise function. So when x equals to 1, so this value is nothing to do with this. It's only you follow the graph, right? The linear line. So when x approaches to 1, the y value approaches. So when x approaches to 1, y value both approach to this 2. So answer 17 is 2. Okay? What y value approaches. Number 18. At which x value, f of x, x squared minus 2x minus 3 over x minus 2 is discontinuous. Let's factor. If you factor top, x minus 3, x plus 1 over x minus 2, there's a no hole. So there's only vertical asymptote at x equals 2. So this value is not continuous because that's the vertical asymptote, right? Vertical asymptote. Okay. Number 19. So first step, you just plug it in. Then what happened? 3 plus 2 minus 1 over 2. When you plug in negative 1 into x. So that's a 5 minus 1 is a 4 over 2. So answer is 2. Just simply plug it in. That value, it is not undefined, then just value whatever you have. That should be answer. This on one side limit, x approaches to 2, but slightly bigger than 2. So that means you don't need absolute sign. So this is same as limit x approaches to 2 plus just x minus 2 and x minus 2. So since you cancel, it will be 1. Answer is 1. Okay. Also, you can look at this way. What if I graph this one? I want to visualize, so to prove that one is actually 1. How are you going to graph that? So when x equals 2, if it's greater than 2, like here, if it's slightly bigger than 2, that approaches to 1. So your graph, like this. Okay? X is, as long as x is, so if I make a piecewise function, it will be, your f of x will be 1 when x is greater than 2. When x is less than 2, that means inside, right? Inside here, if it's less than 2, that means that's inside negative. But absolute cannot be negative. So in order to make it positive, this one, so you have to put another negative outside. Like that, right? 2 negative side. That means when you cancel out negative 1, so it will be negative 1. So you're going to have a piecewise function like that. So negative 1 here, like this. Okay, so question is when x approaches 2 from positive side right here, your y value is 1. So answer is 1. Okay, it's good to know how to graph that piecewise function. Number 21. So find the constant c value. F of x is continuous. To be continuous, when you plug in x equals 2 into this equation and x equals 2 in this equation, you should have the same value. So let's do that. C square minus, when you plug in 2, so 4, that equals 2 times 2 plus c. Now, c square minus 4 equals 4 plus 2c. And then when you move one side, c square minus 2c minus 8 equals 0. Now you factor c minus 4, c plus 2 equals 0. Then c is a 4 and c is a negative 2. Okay, so those two values will be answered. So both these two c value makes that function continuous. Okay, so what I did is you plug in this x equals 2. It doesn't matter. It doesn't have equal sign. How you gonna use substitute? But that's the way. That's the our interest, x equals 2. Okay, so you plug in that x value into first equation, and also that x equals 2 into second equation, and then set equal to each other. That's the time we can check it is continuous at x equals 2. How come we don't check any other point? Because any other point, when x is less than 2, this is a polynomial. So polynomial is always a constant. I mean, always continuous everywhere. Right? So only our interest is x equals 2. That's why I'm checking when x is 2 in the piecewise function, left-hand side and right-hand side, they are equal or not. Okay, so you make it equal and then find out the c value. So these c values makes continuous at x equals 2. Okay. Number 22. Given limit x approaches c, f of x is 1/3. Limit x approaches c, g of x is negative 3 over 5. So find out this value. So 5, you take it out. 5 limit x approaches c, g of x. And then we already know here, so you sub it in. 5 times the negative 3 over 5, which makes negative 3. That's the answer. Okay, so this one you kind of distribute. So limit x approaches c, f of x, plus another limit x approaches c, g of x. And they gave you this one. The first one is 1/3 plus second one is negative 3 over 5. Now you have a common denominator 15. Negative then 9. So answer is, that's not negative. So you can say negative 9 like that. And then negative 4 over 15. That will be answer. Okay. Now C, this also you multiply. Okay. So this is same as x approaches c, f of x times limit x approaches c, g of x. So 1/3 times negative 3 over 5 and cancel negative 1 over 5 will be answer. Okay. Last one, D. So also g of x, you separate x approaches c, f of x over limit x approaches c, g of x. So when you sub it in those given value, f of x was 1/3 over negative 3/5. So that is 1/3 times divided by -3/5 means times -5/3 reciprocal, right? So -5/9 will be your final answer. Okay. Now let's move on. The last one, number 23. So they gave you piecewise function. So 3 functions there. A, is f of s continuous x equals 3? Okay. So when you plug it in, those all function values should be same, right? So when you plug it in the first one, 4 times 3 square minus 6, which is 36 minus 6, 30. And that one is also 30. And then, but now, when x equals to 3, when you plug it in here, so that's not 3, right? So basically, those two value, right, is not matching. So those two matching, but when x equals actually 3, it is a different value. That's a 29, right? So that is not continuous. No. Okay. So that's how you're gonna do. Now, B, what is a f of 3? F of 3 means you use this only second right here. So 10 times 3 minus 1, that's a 29 will be your answer. Okay. Now, next one, C. What is a limit x opposite 3 from negative side? Then from the negative side, then you use this one. Okay. So 4 times 3 square minus 6. We already did there. So that's a 30. That's the answer. What about here? So you use this one. That's also 30. Okay. What about limit? Limit f x opposite 30. That means that is a 30. Okay. It is not undefined. Limit value, you have to look at this one. As long as they are same value, then that's the limit value. What if they are different? That means you have to say limit does not exist. Okay, left hand side limit, right hand side limit should be same in order to have this value. Okay, but it is not continuous because technically there's a hole when you connect these two. Okay, so it is not continuous. There must be hole. And then f of 3 value, you use just second in order to answer it. Okay, that's it for this limit and continuity. And then I'm going to continue with BC, calculus BC limit and continuity practice.